And how are you doing today, everybody? Which is just me and you. It has been ever so long since I've made a video. I hardly recognize myself. I've been studying archaeology. I guess you could say my life is in ruins. Hey, I know why you came to this video. You came to this video because you're trying to convert standard form into vertex form. Because that's going to allow us to graph it, because vertex form is cash money when it comes to graphing. So let's just get started with our video right now. Okay. Well, if you look at vertex form, one of the things you notice is it has a square. And we know how to make squares. We make them all day long. We know we have that capacity. So what I'm going to do here is use our tried and true method for completing the square. So let's get after it. All right. So I'm going to start here with this x squared, and I am going to draw that square. Oh, that's beautiful. Dimensions are x by x. I love it. All right, moving over to the 6x. Because I'm going to take advantage of symmetry as I make a square, I'm going to cut it in half and put 3x worth of area here and 3x worth of area down there. Now this dimension is going to be plus 3 because x times 3 is 3x. This is also going to be 3. Now we get to literally complete the square. I hope this marker works. I didn't check this marker. Let's see. I'm gonna see. Oh, it kind of works. It works pretty good. So we got to complete that square. It's 3 by 3, which is 9. So x squared plus 6x plus 9 would be a perfect square. Well, we have minus 1, not 9. No problem. Let's just add 10. Let's just add 10. Let's go get it, all right? Plus 10. Now, whatever we do to one side of an equal sign, we must do to the other side as well. So let's go over here. And now we have that y plus 10 is equal to x squared plus 6x plus 9. Isn't that beautiful? Isn't it beautiful? Because this is a perfect square. So now I know that an area of x squared plus 6x plus 9 is x plus 3 squared. So that's still equal to y plus 10. Oh, we are one step away. This looks an awful lot like our vertex form. Last thing we got to do is we got to get y all by itself. Well, that's no problem. That's no problem for us, because what we're going to do is just simply move the 10. So let's just subtract 10 from both sides. That goes to 0. And we have y is equal to x plus 3 squared minus 10. Beautiful. Now we can graph this by using our skill set with vertex form. All right, well, let's just go ahead and do that. We know that the vertex is going to be when this squared term equals 0, which is going to happen when x is negative 3. So let's go back to negative 3. That's going to make this equal to 0. When the squared term is 0, y is negative 10. So let's go down to negative 10, and you just graph a parabola following the pattern of the parent function. Beautiful. Wasn't that fun? You probably thought it was going to be intimidating. Now that we're done with it, you're like, okay, Mr. Miller, I feel you. I feel what you're doing. Let me put up another one, and you get to try it this time. All right. Try this problem. Hit pause. Unpause. All right, well, let's go get after it, okay? Again, we're going to convert it to vertex form, which means we get to make a square again. Beautiful. I love making these squares. You can do it in like the margins of your paper or whatnot. You can tell a nice quadratic math class. You show all these squares everywhere, right? Okay, so I have minus 4x. I'm going to split that up and put negative 2x worth of area there and negative 2x worth of area over here. I know it feels a little strange sometimes to have a negative area. But just roll with me, okay with it? It's okay. Little product of the algebra. This dimension would have to be minus 2 and minus 2. Because x times negative 2 is negative 2x. Now we got to complete the square. So fun step. Oh my God, the marker is starting to fail for me. No worry, you can see that 4, right? You can see that 4, right? Okay, so there it is. Well, hey, I got a 5. I want that to be a 4. If that 5 was a 4, I'd have a square, and then it would start looking like my vertex form. So you know what I'm gonna do? I'm gonna subtract 1. Awesome. Last time we added, this time we subtract. It is all good. So that means that y minus 1 is equal to x squared minus 4x plus 4. Brilliant. Look at how beautiful that looks now. Because what am I going to do? I'm going to say, oh, I know what that is. That means we are at y minus 2 squared. Gorgeous. Let's add 1 to both sides so we get y by itself. And that, my friends, is how you do that. You probably like, well, hey, I think we're supposed to graph it, Mr. Miller. You haven't even graphed it yet. Oh, well, I think you just need to be a little patient. I'm gonna graph it right now. Don't worry, you'll be home for dinner. We gotta graph this right here. So, you know, I'm just gonna graph the vertex form pretty rapidly. I gotta think. The squared term has to be positive. Therefore, the minimum will be when the square is equal to 0, the smallest it could possibly be because it can't be negative. So that's gonna be when x is equal to 2. Right, so I'm going to go over to 2. I know when x is equal to 2, you put 2 in for x. You see here, you put 2 in for x. This goes to 0. And when that's 0, y is 1. Say it with me. 1. So I'm going to go over here up to 1. And draw a parabola that is the pattern of the parent function because the a value is 1. Well, hey, I don't know if this video was it was like 2 years in the making, I suppose. I made one 2 years. I don't know if this one was worth the wait or anything, but I hope it finds you well. Hope it finds you in good spirits, and you know, have fun on your journey here. Take care.